So I'm going to try question number 2, and I'm going to try the adder method that I came up with for question number 1 to see if it works. If it doesn't work, then we can always default to other options like guess and check and other strategies. But maybe now that we have this method, we'll have something really reliable that we can use. In question number 2, it's telling us that the second term is 7 and the fourth term is 19. And they built us a table so that we could see this all set up. Now it's our job to find the adder using any method. I'm going to use the method I highlighted in question number 1. Let's see if this works. We're going to subtract the t of n numbers, subtract the n numbers, and then divide them. Let's see if that works. First, the t of n numbers. That's the bottom row in the table. So these are the t of n numbers, 7 and 19. You can subtract them in any order that you want to, but I usually like to do the right minus the left. It doesn't matter, but you just have to be consistent. Whichever one you start with, whether you're starting with the right number or the left number, you're committed to the same order when you subtract the other pair. So I'm subtracting the t of n numbers, 19 minus 7. Then I'm going to subtract the n numbers, 4 and 2 on the bottom. So notice t of n goes to the top and n on the bottom. I'll just kind of circle those so we can see them. T of n numbers were 19 and 7. The n numbers were 4 and 2. If I do this subtraction, 19 minus 7 is 12. 4 minus 2 is 2. 12 over 2, or 12 divided by 2, is 6. So this is telling me that my adder must be 6. Now, the reason why that's helpful is because now I can figure out what's missing in the table. Now I know that the adder is positive 6, which is telling me I must be adding 6 to get to all the numbers in the table. Let's check and see if that works. 7 plus 6 would be 13, and 13 plus 6, yep, sure enough, is 19. I know that the adder really is 6, and I didn't have to guess. I quickly figured that out. Now I can go backwards and I can figure out what was missing for my initial value. So if plus 6 and plus 6 takes me forwards through the table, then 19 minus 6 is 13. 13 minus 6 is 7. 7 minus 6 is 1. And 1 minus 6 is negative 5. That tells me that my initial value must have been negative 5. So now I have the information that I need. I know that the adder is 6, and I know that the initial value is negative 5. Now I have enough information to build my equation. Remember what my equation looks like? I'm going to build that same equation in letter D. It says, using t of n notation, so that just means write t of n equals, and then we have initial, negative 5, plus the adder, which is 6n. For the record, if the adder is negative, then you would call it minus 6n. But since positive 6 was adding 6, that's the plus sign that I chose to use. For now, I'm not really worried about letter C. I think letter C is a pretty doable question without using another way. And I'm at the point where I might think, let's not fix what ain't broken. I'm going to skip letter C so that we can really focus on what's working. Let's use our new formula to find the adder, and then simply work backwards in the table to find the initial value. We just needed to remember that the initial value is always the 0 term, but we've seen enough of that to know that's pretty consistent. Now it's your turn. Now see if you can use this strategy for question number 3. In question number 3, the only thing that makes it different is that it's missing the table. Question number 3 doesn't give you a table, but it's certainly very possible to just make your own table in the scratch space. So if I was doing number 3, letter A, you can just make your own table along with me, and we can interpret this information. We could say t of 3, that's the third term, is 20. And then they say t of 7, so that's the 7th term, is 40. That's just like some of the other tables that we've had. So we know that we're missing the 4th and the 5th and the 6th terms that we need to figure out. We also know, because of how these tables go, that we need to be able to go all the way back to the 2nd and the 1st and eventually the 0 term to be able to get the initial value. I obviously made my table way too tiny. You might have to use scratch paper or something and do a better job than I did. But you can very easily set up a table just like with the other questions so that you can see what to do. And I'll just kind of talk you through this one without writing it. I can tell I'm going to use my adder strategy, the same strategy I used in the previous question. Subtract the t of n's. Remember, t of n is the bottom row of the table, so that's going to be 40 minus 20. Then on the bottom of the fraction, we'll subtract the n values. Those are the top row of the table. I had a 7 minus a 3 that they gave me, and this hopefully will give me what I need for my adder. So now that you know that you can find the adder, the question is simply, how do you go backwards? How do you get back to the initial value? And then how do you use your initial value and your adder to go to the equation? So notice I put a couple little arrows there. Your work from here plus your highlighted initial value you'll need for your equation. Once you've seen that example, you should be good to go for the rest of question number 3. Use the answer key as your guide, and if you feel like you need more examples or if you feel like you just don't get it, then pop into the next office hours and I'll be glad to walk you through another example if you feel like it would help.